we're going to talk about the properties of logarithms. So if you, that was weird, logarithms. So if you are following with me, sorry about that, through the different videos, I kind of introduced, I peppered in the properties of logarithms throughout my previous videos to talk about how to solve problems and things like that. In this one, we're going to explicitly call out a couple of properties of logarithms, and we're going to start looking and solving problems using these properties, expanding, condensing, things like that of our logarithms. So the first property of logarithm that I'm going to cover is, I'm just going to say 1, is going to be the log of base b of m times n. I'm going to put this in parentheses here, is equal to log base b of m plus log base b of n. This is called the product property. Of logarithms. So an example of this would be log of base, well, I'm just going to do a common log of, I don't know, I'm just going to actually do 20. I can break this apart as log of 10 plus log of 2, and then I could simplify this even further because remember, log base of base, what power do I have to raise 10 to get 10? Well, I have to raise 10 to the power of 1 plus log of 2. So again, we can use this to simplify or reconstruct our logs. Another place that you will see this is for transformations. So we might have something like log of 2x. I'm going to do this log base 2 of 2x just to make this a little cleaner. And we don't have vertical or horizontal scaling. So I can change this into a vertical shift by doing log base 2 of 2 plus log base 2 of x. And again, this is going to be 1 plus log base 2 of x. All right, so the product property can allow us to manipulate our functions, our expressions into something that, one, we can graph, one, we could use verticals as opposed to horizontals, because horizontals do make things a little bit messier in my opinion. And so this is a couple of ways that we can use that product property. Okay, trying to get my yellow back. So if you need to pause and write this down, go right ahead. I'm going to go to the second property, which is the quotient property. So the second property is going to be log of base b of m divided by n. So when we were multiplying, we added. Here, since we're dividing, we're going to subtract. And we're going to, this is called the quotient property. P-R-O-P-E-R-T-Y. So again, an example of this would be log of, let me think here, 1/2. Do I want to do 1/2? Yeah, I'm just going to do, you know what? No, I'm not going to do 1/2. I'm going to do log, yeah, you know what? I'm going to do log of base 2 of 1/2. So this is going to be log base 2 of 1 plus, or minus log base 2 of 2. And then this one will actually turn out to be 0. Because again, when you're thinking what power do I raise 2 to get 1, anything to the power of 0 will equal 1. So this will end up being 0. This would be -1. So my solution here would be -1. Again, it's cleaning it up. It's simplifying. I know I'm expanding, but sometimes with the expansion, you can get a simplified answer. All right, so that's the quotient property. Again, if you need to pause and write this down, go right ahead. I'm going to move on to the third property that they mention, and they being enVision Algebra 2. This one is log, this is 3, log base b of m to the n. I have mentioned this one a couple of times, and this would equal, or this is equivalent to, n log base b of m. And this is the power property rule. The power property of logarithms. So again, if I had log of 2 to the x power, I can actually take this x and move it to the front for a log of 2. You see me do this a couple of times. You see me use other log bases to isolate x, but this is the power property. This is the name of that logarithmic property. So we're going to jump in and I'm going to prove a property. So here we go. As soon as this example wants to load. So we're going to have this property. We're going to let x equal log base b of m. And we're going to say that y is equal to log base b of n. We then know that b of x is equal to m, and b of y will then equal to n, just from the conversion method. So again, b raised to the power of y equals that n. Alright, so if I take b of x and b of y and I multiply them, I know that this is going to be m times n through substitution. Okay. I also know that there's a power property for this guy where you have bx plus y to compress this will equal m times n. All right. Now let's say I raise each of these to log base, go back, not raise them. So this is going to be log base b. I'm going to log both sides. Log base b of mn. Well, remember we had that log base b. This goes back to that power property. Basically, log base b of b is 1. So we're left with x plus y on the left, and I'm left with log base b of m times n on the right. All right, now I'm going to substitute in for x and y. X is log base b of m, and y is log base b, it's right here, log base b of n, and that will equal log base b of m times n. And there we have proven our property, our first property. All right, so let's prove the quotient one. So let m equals log base b of, wait, I might have done that backwards. Let x equal log base b of m. X equal log base b of m. And y equal log base b of n. And then b of x equals m, b of y equals n. So let's say that b of x divided by b of y is equal to m divided by n. This is substitution. All right, knowing the exponential properties, these are going to be subtracted. We have the same base, so my exponents get subtracted. So x minus y equals m divided by n. Take the log of both sides. So log base b of this, log base b of that, nicely written in there. And we get base b of b, x minus y, equals, because again, log base b of b, x minus y, I'm just going to use x in this case, would equal x log base b of b. And remember, what power am I raising b to get b? Well, I'm raising b to the power of 1 to get b. So this is x times 1. So this is just x. So in our case, this is just x minus y. Log base b of m minus n. Using substitution of x is log base b of m minus substitution of y, log base b of n, and that just equals log base b of m divided by n. All right, so there is the proof for the quotient rule. All right, guys, so this is the end of this video. I threw in the try it in there so you can see both being proved. And I hope to see this in your notes. If you guys have any questions, please feel free to contact me, and I'll see you in the next video.